Everyone, today in this video I am going to explain the basic concept of matrix and its different forms. So let's start with the matrix. A rectangular array of numbers or letters or expressions enclosed within two square brackets is called a matrix. A rectangular array, that means array or a series in the rectangular form like 4, 5, 9, 3, 2, 1, 1, 6, 3. So enclosed within two square brackets. So this is called a rectangular array of numbers. In the same way, we may write the rectangular array of letters like as A plus 1, B, C, X plus 1, Y, Z, and U plus 1, V, W. And it is not necessary that there are equal number of rows and columns. These are called rows of matrix and these are called columns of matrix. So a matrix can have any number of columns or any number of rows. It may have equal number of rows and columns as well as unequal number of rows and columns like this. This matrix has two rows, one row and second row, and three columns, 1, 2, 3. In the same way, a matrix may have only one row and three columns, or one column and three rows. These are rows and there is only one column. So this is the basic concept of a matrix. Now we are going to discuss some special kinds of matrices. So the first one is a row matrix. So a matrix which has only one row and any number of columns is called a row matrix. A matrix having only one row and any number of columns, is called a row matrix. Row matrix. For example, this is a row matrix because it has only one row and two columns, 3, 7, 9. This is also a row matrix because it has only one row and three columns. So a matrix which has only one row and any number of columns. Columns may be 1, 2, 3, 4, 5, but there should be only one row. That is called a row matrix. In the same way, we may define a column matrix. A matrix having only one column. A matrix having only one column and any number of rows. Any number of rows is called a column matrix. A column matrix. For example, three, 7, 9. It is a column matrix because it has only one column and 3 rows. So how many rows it has, it doesn't matter, but it must have only one column. So it is called a column matrix. 8, 9. It is also a column matrix, etc. Yes, a question must arise in your mind that if it has only one element, what do we call it? Because it has only one row and one column. So the answer is, this is a row matrix as well as a column matrix, because it satisfies both the definitions. So it may be termed as a column matrix or a row matrix. Now the next one is a square matrix. So the square matrix is defined as a matrix having equal number of rows and columns. A matrix having equal number of rows and columns is called a square matrix. So, for example, a matrix having 2 rows and 2 columns like this, it has 2 rows and 2 columns. So it is a square matrix of 2 by 2 order. Order is written as 2 by 2, that means the first number indicates the number of rows and the second number indicates the number of columns. So the matrix 3, 5, 7, 4, 9, 6, 8, 3, 2. This is also a square matrix because it has equal number of rows and columns, 3 rows and 3 columns. In this way, a square matrix may have 4 number of rows and columns and 5 rows and 5 columns, 6 rows, 6 columns, but the condition is the number of rows and number of columns should be equal. The next one is a null matrix. A null matrix. So a null matrix is a square matrix which has only 0 as elements. Means a square matrix is said to be a null matrix if every element of the matrix is 0. A square matrix in which every element is 0 is called a null matrix, a null matrix or 0 matrix or void matrix. A void matrix. It is known by 3 names: a null matrix or a 0 matrix or a void matrix. So, for example, matrix 0, 0, 0, 0. is a null matrix of order 2 by 2, which is generally denoted by O 2 by 2 or simply O2. In the same way, the matrix 0 0 0 0 0 0 0 0 0 is a square matrix, is a null matrix of order 3 by 3, which is generally denoted by O3 by 3 or simply O3. In the same way, a null matrix of 4 by 4 order, we may define any number of a null matrix of any order like 4 by 4, 5 by 5, 6 by 6. Now the next one is the identity matrix. A square matrix in which every diagonal element is 1 and every non-diagonal element is 0 is called an identity matrix. It is generally denoted by capital I. For example, matrix 1 0 0 1. This is called diagonal of the square matrix, and if you see, the diagonal elements are unity. Every diagonal elements means the elements lying in the diagonal. These are unity or 1, we may say, and these are called non-diagonal element because these elements are not lying in the diagonal. So every diagonal element is unity or 1, and every non-diagonal element is 0. So this is called an identity matrix. And this is identity matrix of 2 by 2 order, which is generally denoted by capital I suffix 2 by 2 or simply capital I 2. Identity matrix of 3 by 3 order is written as 1 0 0 0 1 0 0 0 1. As you see, the diagonal, every diagonal element is 1 and every non-diagonal element is 0. So this is an identity matrix of 3 by 3 order, which is denoted by capital I suffix 3 by 3 or I3. In the same way, we may write the identity matrix of 4 by 4 order or 5 by 5 order or any other order. A very important property of an identity matrix is that if we multiply a non-unity or non-identity matrix by an identity matrix, the result is the non-identity matrix. That is, if we multiply I and some other non-identity matrix A left-wise or right-wise, the result is always the matrix itself. So I into A or A into I is equal to A, where I is the identity matrix and A is any other matrix. This is just like multiplication of 1 as 1x. Identity matrix acts as 1 in ordinary multiplication, as we know that 1 2s are 2, 1 3s are 3, 1 4s are 4, 1 5s are 5. If we multiply any number by 1, the result is the number itself. In the same way, if we multiply any matrix by identity matrix, the result is the matrix itself. Now come to the sixth type of matrix, that is scalar matrix. So a square matrix in which every diagonal, we say in which all diagonal elements are equal and every non-diagonal element is 0 is called a scalar matrix. For example, the matrix 5 0 0 0 5 0 0 0 5. In this matrix you see all the diagonal elements are equal and every non-diagonal element is 0. So this is a scalar matrix. So as you see in the definition of a scalar matrix and the definition of an identity matrix, there is a little similarity. In identity matrix as well, all the diagonal elements are equal, but equal to 1. This is the condition. Otherwise it is not an identity matrix. But in scalar matrix, the condition is only all the diagonal elements should be equal and non-diagonal elements are 0. So in this way we may say that every identity matrix is a scalar matrix, but every scalar matrix is not an identity matrix. The next one is diagonal matrix. A square matrix in which diagonal elements are non-zero and non-diagonal elements are 0 is called diagonal matrix. As for example, the matrix 4 0 0 0 0 5 0 0 0 7 is a diagonal matrix. A square matrix in which diagonal elements are non-zero and non-diagonal elements are 0 is called a diagonal matrix, and it is denoted by diag bracket, and we list all the diagonal elements. This is the way to represent a diagonal matrix. We write diag, and within a parenthesis we write all the diagonal elements. This is the way to denote a diagonal matrix. So as you see, the identity matrix and a scalar matrix and a diagonal matrix are similar in one way, that in each type of matrix non-diagonal elements are 0, and they are being differentiated on the basis of the diagonal elements. If all the diagonal elements are in 1 or unity, it is said to be an identity matrix, and if all the diagonal elements are equal and non-zero, then it is said to be a scalar matrix, and if all the diagonal elements are non-zero, there is no restriction of equality or of being unity like identity matrix or scalar matrix, but only non-zero elements should be there in the diagonal, and in the non-diagonal elements every element should be 0. So this is diagonal matrix. The next one is upper triangular matrix. A square matrix in which every element below the leading diagonal, is 0, is said to be an upper triangular matrix. For example, matrix 1 3 4 0 5 6 0 0 2. So if we see, the leading diagonal is this, and below the leading diagonal every element is 0. So a square matrix in which every element below the leading diagonal is 0 is said to be an upper triangular matrix. In the same way, we may define the lower triangular matrix, and it is defined as a square matrix in which every element above the leading diagonal is 0, that is said to be a lower triangular matrix. So these are 9 special kinds of matrices which are very frequently used in the study of matrices. Some other comparative types of matrices I will discuss in my forthcoming videos. So stay tuned.